Now you can call these terminals A and B if you wish. And I'll say that the independent voltage source's value is 0. Okay. So what will this be equivalently between A and B? My question is, we have an independent voltage source whose value is 0. So what is that equivalent to? Okay, so as many people mentioned, it is equivalent to a short circuit, because again, if this V equals 0, the voltage at node A has to be exactly equal to the voltage at node B. Okay, so that is like tying these two nodes together with a wire. Okay, so this is a short circuit. And similarly, let's say I have a current source whose value I equals 0. What is this equivalent to between A and B, nodes A and B? Again, the answer is pretty obvious. This is equivalent to an open circuit. An open circuit by definition doesn't allow any voltage, any current between them. Okay. So if you have an open circuit between two nodes, that means no current can flow from A to B. And this I equal to 0 means exactly that. Okay. And similarly, for a resistance, R. So let's say R equals 0. Okay. And the voltage drop will be I times R. If R equals 0, the voltage drop will be 0. That means VA will be equal to VB. Okay. And it is equivalent to a short circuit. So resistance of 0 means that it will short the two nodes between which it is connected. And a resistance of infinity would mean that it's an open circuit. Okay. Because if a resistance is infinity, that means whatever voltage you have across this, the current through this, which is VR divided by R, as R tends to infinity, will go to 0. That means no current can flow between these nodes through this branch. So that is an open circuit. Okay. So an infinitely large resistance is like an open circuit. Okay. Now, why are we looking at these things? Sometimes we have to evaluate these extreme cases. Sometimes also you want to reduce the value of some element to 0 or infinity and then see what happens to the circuit. Okay. So if you know that it's a short circuit or an open circuit, you can very easily evaluate that. Okay. And let's say you have an inductance L and L equals 0. What would this be equivalent to? Oh, as many people said, this will be equivalent to a short circuit between A and B, because the voltage across the resistor equals L times the time derivative of the current, and it will be 0 if L equals 0. Okay. So regardless of the current, the voltage will be 0. That means a short circuit. And similarly, if you have a capacitor which is 0, this is an open circuit. Okay. Okay. So we looked at extreme cases of certain elements. Okay. Because of some problem, my browser closed instantly, and then because of that, the connection got broken. But now it is back up, I believe. Okay. We looked at extreme cases of these elements, and in some cases they become open circuits, and some cases they become short circuits. Okay. Now we can look at a couple of other special cases. So let me say that I have a voltage source V equals V naught and a current source I equals I naught in parallel. My first question is this connection allowed? Okay. For instance, we could not connect two voltage sources in parallel or current sources in series. Now I have a voltage source and a current source in parallel. Is this okay? Okay, looks like all of you agree that it is possible. Now I have these two terminals here. What will it look like between these two terminals, this combination? We have a parallel combination of a voltage source V naught and a current source I naught. So from the two terminals, what will the combination look like? Now when I say what it looks like, you have to tell me if it looks like some simple element that we have already discussed. Okay. For instance, when we had two voltage sources in series, it still looked like a voltage source, but whose value was sum of the individual values. Okay. Similarly, what will it look like here? I hope the question is clear. Now, the way to answer this question is like you do for any other circuit. Okay, so you have these two terminals, and you have to either apply a voltage and find the current. So let me draw a box around this. What I am trying to find out is what the circuit looks like between these two terminals. What do we have to do? We have to either apply a voltage and find the current, or apply a current and find the voltage. Okay. So let me ask you this. If I apply a current I test, okay, and measure the voltage here that is developed, what will that be? Okay, it looks like the question was not clear. My question is, I have this voltage source and a current source in parallel, and this is not very different from having, let's say, two resistors in parallel and so on, right? In principle, it's similar problem. You will end up with two terminals, and you have to find out what the circuit looks like at those two terminals, okay? Because I can have a box around this whole thing, and I can call it a two-terminal element, okay? There are only two terminals. Now, the way to determine what any electrical two-terminal element looks like is to either apply a voltage and find the current, or apply a current and find the voltage. Okay, so in this case, I have also applied the current I test, and I am asking you to find out what the voltage developed is. So, what is the answer? Clearly, this voltage source will enforce the voltage between these two nodes to be exactly equal to V0, regardless of what current is flowing through that. Okay. So, the voltage across these two terminals will be equal to V0. Okay. And this is also independent of the current we have applied. Okay. So, what does it mean? If the voltage value is independent of the current that is applied, that means that what is the equivalent element? So, we have this voltage source here. What does it mean to have an independent voltage source? It means that the voltage between its terminals will be always equal to V0, okay, independent of how much current is flowing. And those two terminals are exactly the same terminals that are coming out. So, between these two terminals here, we have V0 independent of I test, whatever current you apply, okay. By Kirchhoff's law, you know that the current that is flowing through the voltage source is I test minus this I0. But that is not relevant. How much ever current is flowing through that, it will always maintain V0. So, this entire thing is equivalent to a voltage source of value V0. Okay. Now, it doesn't matter if you connect a single current source or multiple current sources. I could also connect a resistor here. Okay. In fact, I can connect anything I want. I can have a voltage source and connect any other complicated circuit. I will not show what it is, but it is not relevant, because this voltage source will say that the voltage between these two values is V0. Okay. So, this whole thing is equivalent to just a voltage source of value V0. Okay. Any questions about this? Now, somebody asked, if you measure the current, will it become a current source? No, that's not the case, because whichever way you measure it, first of all, because it appears like a voltage source, you will not be able to connect a voltage source and measure it. you will get an inconsistent condition. Okay. Now this can sometimes happen. I said that to test what a circuit looks like between two terminals, you can either apply a voltage or apply a current. And if you apply a voltage, you measure the current, and if you apply a current, you can measure the voltage. Now there will be circuits where one or other of these things will not be possible. Okay, that is, let us say that I have this silly circuit inside a box. Okay, I have these two terminals, and this is a black box. I just close it and give it to you. Okay, and I have a short circuit. Now what happens? Clearly, you cannot apply a voltage to this. Okay, if you do this, you will see that you will get an inconsistent condition. Okay, in fact, somebody asked this question right at the beginning of the lecture. If you have a voltage source and you apply a short circuit across a voltage source, what happens? You can see that this is the sub case of having two voltage sources in parallel and one of the voltage sources being 0, because a 0 volt voltage source is a short circuit. So a voltage source which is short circuited is equivalent to two voltage sources in parallel whose values are not equal. Okay, so that's not possible. So in this case, you cannot find what is inside by applying a voltage source, because that gives you an inconsistent condition. Now this can happen many times. Okay, so now this circuit is so simple. By looking at it, you see it's a short circuit, but in reality, the circuit that you are analyzing may not be so simple. So it could be that you apply a voltage source and go through the calculations, and you will find that you cannot, you will get some inconsistency, or you will start getting infinities in the calculation. In that case, you abandon that and you apply a current source and see what is happening. Okay. Okay. Now for the same circuit, if I apply a current, let me not say V0, this was V test. This was what I applied to find out what is in the circuit, and I apply I test to find what is inside. So what it means is, what it says is, because this is a short circuit, regardless of whatever current is flowing there, this node and that node will be at the same voltage. Okay. So this voltage will be 0, and this is 0 regardless of I test. So what does it mean? You can think of it as either a 0 volt voltage source, or a 0 resistance, or a short circuit. Okay, all of these are anyway equivalent to each other. Okay, all of them are short circuits. So that's why in this particular example, we cannot apply a voltage source and find the current, because there is already a voltage source inside. If you apply V test here and you work out the KVL equations, you will see that the total voltage around the loop would be V test minus V0, which is not necessarily 0. Okay, so that can happen. So it's not that if you apply a voltage here and find out the current, it looks like a current source. You cannot do that at all. Okay. I hope this last part was clear. What I was trying to say is, in principle, you can apply a voltage source, find the current, or apply a current source, find the voltage. For some particular circuits, one or the other of these may not be possible. Okay. Now, one of the other questions is, do current sources exist in practice? And yes, they do. Now, in this course, we will not worry about how to make them. But those of you who take courses on analog circuits know that there are elements known as transistors, with which you can make some things that are very good approximations to current sources. Okay. And sometimes some natural sources of signals like photodiode and so on also behave more or less like current sources. Okay. Now the counterpart of this is a current source in series with some element. What is this equivalent to? I think all of you should be able to answer this pretty quickly now. When I say equivalent to, between terminals A and B. So again, a few of you have answered. It's very clear that current I0 will be flowing here because of the current source. And if you think of this entire boundary, the current I0 has also to be flowing there because there is no local charge accumulation anywhere. Okay. So the current cannot go off into some other place. So between these two, it is equivalent to a single current source of value I0. Okay. So as far as the terminals A and B are concerned, a current source, an ideal current source in series with something will look exactly like a current source. And this also applies to if you have a current source and a voltage source in series. The equivalent is a current source. Just like when we had a current source and voltage source in parallel, the equivalent was a voltage source. Okay. So is this clear? Now all of these things will become useful. Sometimes what happens is in circuits, you will find these things in this fashion. Okay. The voltage source will be in parallel with probably a very complicated thing. You don't have to worry about that, all that complicated stuff, if all you are interested in is the voltage bit across the voltage source terminals. Okay. That will be equal to V0 regardless of what you connect to it. Similarly, a current source will maintain a current flow of I0 regardless of what is connected to it. Okay. Now there will be some difference between these pictures. Okay. That is when I say voltage source and current source in parallel, and let's say this is connected to, or let's say it's just not connected to anything else. Now we know that this is equivalent to a single voltage source. When I say equivalent, we have to be careful where they are equivalent. As far as these two terminals are concerned, A, B, they are equivalent. Okay, that is, if I gave you this whole thing in a box and this thing in a box, you will not be able to tell the difference. Okay, without opening the box. Now there will be, something different. That is, for instance, let's say nothing is connected to it. In this particular, in the upper box, a current of I0 is flowing through V0. Okay, and here nothing is flowing through V0. So the internal details will be different. But as far as the terminals, the external terminals are concerned, the behavior will be exactly the same. Okay. So when we say equivalent, we have to also be careful about what exactly is equivalent between the different circuits. Similarly, if you have a current source and a voltage source, as you see from these two terminals, everything is exactly the same. What will be different is the voltage drop across the current source here and the voltage drop across the current source there will be different. Okay. I hope this is clear. Okay. So now we have extensively discussed what happens when you connect elements in series and parallel. A lot of this is very simple stuff, and many of you already knew the expressions for many of them. But what I want to emphasize is that everything can be derived from the basic laws of circuits, Kirchhoff's voltage law and current law, and the behavior of each element. Okay. We have definitions of what is a resistor, what is a voltage source, what is a current source. From the basics, you can derive all this other external, all this other additional stuff. Okay. Now, before I end the lecture, let me just introduce you to a new type of element, which are known as controlled or dependent sources. We have looked at independent voltage and current sources. These controlled sources will also be either a voltage or a current source. But what is meant by controlled or dependent is that value depends on other electrical variables, that is voltage or current in the circuit. Okay, that is let's say you have a controlled voltage source. Its voltage value will depend on some other voltage or some other current. Okay. Now, based on what kind of source it is and what it is dependent on, we have four types of control sources. We have a voltage controlled voltage source, which means that its voltage is dependent on some other branch voltage in the circuit, some other voltage in the circuit, and we have a current controlled voltage source, CCVS, which means that the voltage source value depends on some branch current. And similarly, we have current sources, we can have a voltage controlled current source, VCCS, and a current controlled current source, CCCS. Okay. Here was lost temporarily, that's why it was broken. But as I was saying, we will look at control sources in the next class, which is not going to be this Thursday, but next Tuesday. Now, are there any questions about this today's lecture? Yeah, there are questions about the recorded session. Yes, the recorded sessions will be put up online. I think there was some delay in putting up the recording of the previous lecture, but everything will be up shortly. Okay. Please go ahead. There is a question. Hello. PRI. Please ask your question. Okay, I think there is a question from Priyanka. When is the test? It's not decided yet, but we'll announce it sufficiently in advance. Okay. Okay, at the other terminal, the network connectivity was lost, so I'll try to answer some of the questions. Now, I hope this Swarna, I'm not sure if you heard my answer. If voltage source and current source are in parallel, how do we calculate the current? Now, the voltage source and current source in parallel is exactly equivalent to a voltage source, and the current will be determined by whatever circuit is connected to it, not by the voltage source. Okay. So if you have details of that circuit, you can find out the current. Then let's see. What is the average current in a capacitor? Now these are, I have to impose some conditions on the operation, but you can consider the average current in the capacitor to be 0. Okay. Now you can violate this by forcing a non-zero average current into the capacitor, but we will not discuss those things here. There is something known as steady state. If your circuit reaches steady state, then the average current in the capacitor will be 0. Okay. Then which book should we follow for numericals? I think the book by Hayton Kemmerly has a very large number of example problems. I think you can use that, and the exact reference and the edition are given on the website. The next session will be the next Tuesday, not this Thursday. Okay. Now there is also another question: what will be IV curves of practical independent voltage and current sources? We will take it up later. Okay, we'll be able to do that. Okay then. Thank you all for attending. We will close for today.